Yeah,
and that's it.
because, so because here's the thing. So if I were to ask you to take the derivative of 3 times something to the third, you would say, all right, the derivative of that would be, so if this was, let's say, hypothetically, 3 times something to the third, the derivative would be 9 times something to the second, because you go 3 times 3, right? Times the derivative of what's in here. You go here. Whereas in this case, what's in here is y. I don't know what y is, so we just call it dy over dx. It's to be determined. So going back to this problem up here, 3 times 3 is 9, y squared, times the derivative of y, which is dy over dx. Derivative of 5 is 0. And then now solve for dy over dx. So I'll move the dy over dx term to the right because it's negative. Divide both sides by 9y squared. So 4x over 9y squared equals dy over dx. Now, if I just asked you to find dy over dx, that would be it. But I said find the slope of the tangent line. So go ahead and plug in -2 for x and -1 for y. So we get -8 over 9, and that's the slope of the tangent line.
What happens with dy over dx? Does that just go away? Because isn't that
it's kind of like this. Like let's say you have f prime of x. So let's say back in the previous, it's just like this. Like f of x equals x squared plus 5x. F prime of x equals 2x plus 5. So if I say, hey, what's the derivative at x equals 3? You would say, oh, that's 2 times 3 plus 5. So it would be 6 plus 5 is 11. So the answer would be 11. That f prime of 3 right here, that's like the same thing as this. But now this is implicit differentiation. You got the x and the y you got to plug in. Does that make sense?
Yeah, that makes sense.
All right, any questions so far? Madison, can you move your hand for a second? Oh, no, you are frozen. Oh, no, you're not. Okay, now, okay. Because you were like this the whole time. I wonder if it's frozen or not. Okay. Now you're frozen and just smiling.
Well, I will say my internet is also really bad, so it is possible that I froze.
Okay. Well, you do have running water.
Yes, I do have running water, fortunately.
All right. Hey, I was going to ask you, your siblings, I know you're, do they go to Fullerton College as well?
Yeah, they do. My brother is taking Calc 2 this semester.
Oh, okay. Yeah. And your mom too, right?
Yeah, they're both taking Calc 2, and then my sister took Trig last semester, but she doesn't want to take calculus, despite our best efforts.
Why not? Take it with me.
I know, we're trying to tell her that, but I think she wanted a break from math this semester. Hopefully we can convince her to do it next semester.
Mm-hmm. Well, she might have been traumatized with whoever her trig professor was. Okay, let's do another one here. Yeah, not too long of a break from math because then you forget everything. All right, find dy over dx by implicit differentiation. And I'm not going to write the directions again. That's going to be the directions for the next couple of questions. So x to the third minus xy squared plus y to the third. You know what? I'm going to turn my iPad around so I can have more room here. So to take the derivative here, then you got 3x squared minus. Now, the derivative of this guy, we've got to use the product rule. So it's going to be minus this whole thing. So I'm going to open bracket. We're going to use the product rule. First, times the derivative of the second. What's the derivative of y squared? 2y times dy over dx. Plus second, times the derivative of the first. What's the derivative of x? 1. So this whole time, I just took the derivative of those two. Plus, what's the derivative of y to the third? 3y squared times the derivative of y, which is dy over dx, equals the derivative of 1, which is 0. So now I'm going to distribute the minus sign here outside of the bracket. So 3x squared minus. And also I recommend, I like to rewrite it, the number first and the x and the y, dy over dx, minus y squared, then plus 3y squared dy over dx. We'll see. Oh, sometimes a student will ask, can I just write y prime instead of dy over dx? You can get away with it in this section, but the issue is eventually we're going to do related rates, which is a couple sections from now, where you're going to have another variable t. So I want to make sure you get used to the notation. All right, so now notice you have some terms that have a dy over dx and some terms that don't. Mainly this term has a dy over dx and this term has a dy over dx, where the other two don't. So move the terms that have a dy over dx to one side and the terms that don't to the other. So I'll leave the dy over dx terms on the left-hand side. I'll put the 3y squared first just because it's positive. It doesn't matter though. I just like to do it this way. And then the two terms that y squared and minus 3x squared. Watch this. Let's go to highlighter. Let's do pink. So the two pink ones, terms that I highlighted, I move those to the right. So you got to flip the sign on them. Does anyone know what I could do next?
Factor out dy over dx.
Yes. And sometimes you can factor out more than a dy over dx, but don't just factor out a dy over dx because that's what we want to solve for. That's why I had only dy over dx terms on the left. Now divide both sides by what's inside the bracket. And we're done. Now, be very careful. Don't cancel anything out. For you to be able to cancel anything out here is you'd have to be able to factor something out on top and the bottom. The bottom, I can factor out a y, but since I can't factor out a y from the top, there's no point of factoring it out to reduce. Any questions?
Professor, can you explain the question one more time? Like just walk through it really fast.
Yeah, so we're finding dy over dx. So the black right here, that's the equation given to you. So the derivative of x to the third is 3x squared. Here, we got to use the product rule. So it's going to be minus sign. This whole thing is the derivative of that. So first, derivative of the second, plus second. So this is the first part. This is the derivative of the second, plus second, times the derivative of the first. Then you got derivative of y to the third, that's just 3y squared, times dy over dx, equals 0. Then I just, from here to here, I just distribute the minus sign. So this minus sign is minus this and minus that. Then these two terms that I highlighted in pink don't have a dy over dx term. So they go to one side. The terms in yellow do have a dy over dx, so they stay on the one side. So you separate them. dy over dx terms to one side, the non-dy over dx terms to the other. So this allows us to factor out a dy over dx and then divide.
Professor, why does the one turn into 0? Because you can't make
But the
it.
derivative of 1 is 0. You take the derivative of both sides.
Okay, thank you.
Let's do one more before we take a break. Or do you guys want to break right now? Yeah, we can take a break if you want. You guys look like you need a break.
Do another one.
Okay, after the break. We'll start at 4:17. 4:18. I feel in a good mood today. 4:18. Is that good, Cassandra?
Yeah, it's perfect. Thank you.